Feels like forever since we've had a video from our book. We worked on our review guide, we took the summative, we did another project, and now we are finally on the second half of cycle 1, 1.9, making and interpreting graphs. So for this first one, use the summary of graphs from a personal fitness tracker, so like a Fitbit, to answer the questions that follow. Round each percent to the nearest whole number. So if you have a Fitbit or something similar, calories burned throughout the day, this is what you might see. And then sometimes they might give you a pie chart that breaks down your activity. And then this one is including sleep. So for 10 hours and 1 minute, you were sedentary. So you were kind of just sitting, sleeping, not really moving at all. 3 hours, 10 minutes, you were lightly active. Maybe you were just walking around, fairly active for an hour and 45 minutes. So not strenuous activity. And then very active for 22 minutes. This is like really getting your heart rate going. You're probably exercising at a sports practice, something of the sort. So for question number 1, we're going to use the pie chart and we're going to use that bar graph of your calories burned. So during what percent of this person's waking hours is he very active? So for question number 1, during what percent of this person's waking hours is he very active? So if you notice up here, I broke down all of these hours and minutes into just straight minutes. Okay, so I times all of the hours by 60 to convert it to minutes, and then I added in the 1 minute, the 10 minutes, the 45 minutes, 22 minutes. I didn't have to actually do anything. And then I calculated the total number of minutes that this individual was awake during the day. So 601 minutes sedentary, 190 lightly active, 105 fairly active, 22 very active. So that was 918 minutes during the day that this person was awake. So during what percent of this person's hours is he very active? So very active was 22 minutes. Okay. And what percent of his waking hours is he very active? Well, the minutes awake was 918 minutes. So we have, remember, part over a whole will give us a percent, and that'll give us 22 minutes out of 918 minutes that he was awake. I cannot do that division in my head. So we have 22 divided by 918, and that gives us 0.024. I'll round. So that rounds to 2.4% of the day he is very active. The hours that he's awake during the waking hours. Now, if you look at the answer key, this is different. I believe my answer key is incorrect. So my answer is correct on this video. Number 2, what percent of the day does he sleep? Okay, so percent, remember, part out of the whole. So part over whole. And that'll be awake, or no, that will be sleep out of the day. Okay, so he is awake for 918 minutes. And how many minutes are there in a day? So we have 24 hours times 60 minutes in 1 hour. And then our units cancel out, remember? So 24 times 60 is 1,440 40, and I'll just include my minutes. So in a day, there's 1,444 minutes. So he is asleep for 1,440 minus 918. So he's asleep for 522 minutes. Okay, so we're going to go asleep. We're going to go back to that fraction. We're going to go asleep for 522 minutes out of 1,440. And if we typed that into our calculator, we got 522 divided by 1,440. And we have 36%. We'll round to the nearest whole number percent. During which periods of the day does most of his light activity occur? So this pie chart is not a good representation because it doesn't tell me what times specifically he is lightly active. We just know that for 3 hours and 10 minutes throughout the entire waking day, he is lightly active. So for this, we'll actually have to go to the bar graph, and it is a little bit up to your interpretation on what you say. You can get specific, you can get very broad. I would say something along the lines of from maybe 6:30. So right here, if this is 7 o'clock, around 6:30 to 9 o'clock a.m. So 6:30 to 9 a.m. he's lightly active. Not so much there. Maybe from he does start being active at like 4 until 6:30. So 4 to 6:30, or you can even go 5 to 6:30 if you wanted to get more specific there. And then I need to move that out of the way. And then maybe around this 8 o'clock hour and around this 10 o'clock hour, I would say that he is lightly active. You can get more general, you can get more specific. It is totally up to you on how you want to answer that question, so long as it represents this graph. What information does each graph give that the other does not? So looking at the bar graph, this first one, it's showing when he exhibits the 4 activity levels, but not the total number of minutes at each level. You kind of have to guess. So if I was looking at very active, well, he's very active on this like one bar here, but I can't tell for how long. If you wanted to know out of the entire day what percent he's being very active for, I can't tell. I have no idea. If I'm looking at the pie graph, it does give you the total times for each activity. We know that he's very active for 22 minutes, but not when during the day, or if it's all at once. Did he sit for 10 hours and 1 minute straight? Was he lightly active for 3 hours and 10 minutes straight? Did he break it up throughout the day? Was he very active for 22 minutes, or was he active for 11 minutes in the morning, or very active for 11 minutes in the morning and very active for 11 minutes at night? Again, you just have to take a guess based on those two different representations. Even though they have all the same data, just having it displayed differently makes a huge difference. All right, then from there we will go to number 2. Here's just an example of cell phone carriers and the number of subscribers for a group of college students. So you have the table here, and then since we're using actual numbers up here, we're using like actually 8 people, actually 3 people. To make this pie chart, you need to convert it to percents in order to display. And remember, percent is part over a whole. So in total, 34 college students were asked. So 8 out of 34 gives you a 24%. This central angle comes, like, if you remember back to your geometry class, It's not something that I'm going to ask you to recall back to. I don't think it's that necessary. I'm fine with us just kind of eyeballing our graphs. And then from there, once they had these percents, they were able to create their pie chart. If you need more help on creating your pie chart, here is a nice little review, test prep tip. Practice now so you can work out any issues and aren't wasting any time on your test. If you have any like technology issues, it's good to know now. So for number 5, Ian attends a company-sponsored workshop that is designed to increase employee efficiency. His task is to create a pie graph showing how he uses his 8 hours at work on an average day to help him analyze how he can better use his time. Represent the information from the table into a pie graph. So just like the example I just showed you, we need to convert all of these hours into a percent of his day. So remember, part over a whole, so the hours out of his whole work day. So if you paid attention carefully in the directions, it says that he works for 8 hours. So that's the total. If you didn't catch that, you can absolutely add up all of these hours. 1.5 plus 2.5 plus 1 plus 0.5 plus 1 plus 1.5 will give you 8 hours. So total 8 hours. And then we're going to go 1.5 divided by 8, 2.5 divided by 8, 1/8, 0.5/8, 1/8, and 1.5/8. And then since we're going right to a percent from this fraction, yes, I know that decimals cannot be in fractions. It doesn't work that way. It's math illegal. But since I'm going to a percent right away, we'll let it slide. I already have these calculated, so I'm not going to waste time calculating these for you. 18.75%. We have 31.25%, 12.5%, 6.25%. I'm getting so much work turned in. Oh my goodness. 12.5% and 18.75%. Okay, now notice that all of our denominators, or the bottoms of the fractions, are out of eighths. So let's try and divide this pie chart into eighths. And then we'll color in what we need to. Okay, so we have, well, this 1/8 is calls. Okay, so 1 pi. So this is calls. And then we have lunch is right here. So 1 is lunch. And then we have 1.5 is meetings. So I'm going to go 1, and then I'm going to divide this in half. And then I'll just highlight. So this section is meetings. And then the other 1.5 we'll do is off task. I'll highlight in a different color. And this is just if you want to be like really technical with your pie chart. Otherwise, you can carefully eyeball it. And then what do we have? Okay, so we have off task is done. Let's do breaks as a half. And then the last 2.5, he is on his computer. So one last color, and those 2.5 little slices are on his computer. All right, So you can also add in, we need a title so we know what's going on. Ivan's average workday. Okay, so now he can see that he is spending most of his time. I labeled lunch twice. This lunch should actually be off task. Okay. We can see that most of his day is on computer. Then the next part of his day is either in meetings or he's off task. Small part of his day is calls and lunch, and then very small portion of his day is spent on a break. Moving on, why did we need to change that table? Well, charts are boring. They're frustrating to read. To be totally honest, if I see a chart or a table like this, I'm probably just going to gloss over it, especially because these aren't in numeric order. Like, this one is the highest value, and this one is the lowest value. I just don't like that. I would like to see it from highest to lowest if I'm looking in a chart. So that's just really not helpful. I don't like that. Graphs, these bar graphs, much easier to interpret. From here, like I said, I like it from greatest to least. I can see that California has the most expensive gas prices. Nevada, Hawaii, and Illinois are about the same, and Michigan, Oregon, Indiana, and Wisconsin have the cheapest. They're all around $2. Now, what this pie chart or bar graph isn't telling us is the specific to the cent price. If you really care about the price, yeah, maybe the table is better. They could have done a better job if they had listed it from highest to lowest price instead of listing the states alphabetically. I guess unless you want it listed alphabetically, if that's how you choose to sort it. But I guess that's kind of up to the person who's reading it. Another little notes page on how to create a bar graph. I'm hoping that most of you have made a bar graph in your life and feel confident making your own bar graph. If not, here are examples on that. This problem is really good for anyone who's interested in medicine or interested in a career in the medical field. Last year, I had a ton of students that were doing the CLC program for nursing, and they found this problem mildly interesting, as much as you can find a math problem interesting. But they were like, oh, okay, I guess that was decent to know. So this is our last problem that we will go through. Let me check. Yeah, this is the last problem we'll go through. So the data that accompanies over-the-counter and prescription drugs is full of important, often mathematical information, even though most people just totally ignore all the math behind it and just probably just go to their medicine cabinet and take, 1 Tylenol, 2 Tylenol, whatever. In the following graph, the vertical axis, so the one that's going up and down, represents the concentration of acetaminophen. So that's like your Tylenol, I believe. Yeah, that's like Tylenol in the body, measured in micrograms per milliliter of blood. And that's the symbol for it. That's like a Greek letter. I have no idea what it is. Go ask a medical professional. The horizontal axis represents the number of hours that have passed since the medication was ingested. The graph is constructed in this way because the amount of acetaminophen or Tylenol in the bloodstream depends on how much time has passed since the medication was ingested. Since all of the data values are positive, only the first quadrant is shown. The graph shows 2 different types of medication. So the first one in the blue solid line is adult liquid, and then the yellow dashed line is your extra strength tablets. So liquid versus a pill, essentially. All right, write the ordered pair of the point indicated by the arrow and interpret it. Do not use abbreviations for units. Wow, that sounds rude. Okay, so what is the coordinate? Coordinates are x, comma, y. So if I look at the graph at this point here, x value is 2, y value is 12. So 2, comma, 12. Now we need to interpret that point in the context of the problem. So x values was time in hours. X equals time in hours. Y equals the acetaminophen. I'm just going to write Tylenol because acetaminophen is too hard and long for me to spell. And then I am going to abbreviate this symbol because, again, it's really long and I don't want to write all that. So x values, x is 2, so 2 hours. And what are we doing after taking the Tylenol? Okay, 2 hours after taking Tylenol, what happens? Y represents the Tylenol in your bloodstream is 12. What unit was that again? Micrograms per milliliter. Okay, so there are 12, and I'm just going to abbreviate of Tylenol in the blood. Okay, cool. Okay, so we just identified the x value, identified the y value, interpreted the x value, interpreted the y value. That's all I did there. Okay, number 2, use the shape of the graph to describe what happens to the concentration of the medication in the body over 8 hours. So the whole graph is from 0 hours when you first took it to 8 hours. Why is the second dose needed after 4 to 6 hours? So, all right, first let's look. So it looks like but in the first hour of taking the medication, here's the first hour, the concentration is the highest in your body. So highest level within that first hour. And then after that, this is an exponential function, if you remember that term back from Math 1. Maybe you saw it in Math 2 or Math 3. I don't know. And then why do we need to take a second dose after the 4 to 6 hour range? So from here to here, there's still some residual drug in the body, but it is considerably lower than what it was during that first hour. So that first hour, let's say there's between 18 and 29, whatever that symbol was, 18 to 29, but at hour 4 to 6, there's between 6 and 3 in the body. So a lot lower. So that's why they recommend to take that second dose 4 to 6 hours later, just to keep that painkiller going. When do the two formulations result in the same concentration of acetaminophen in the bloodstream? Okay, so basically, when do these graphs overlap? So we overlap, obviously, at hour 0 when we first started. We also are overlapping right here at, like 45 minutes. And then we overlap from here all the way to here. So hour 0, 45 minutes, and then 6 to 8 hours. The drug is about the same in the body. That's it for the notes section. Just make sure that you complete your homework section, and then you are good to go.